Left channel, right channel, center.
NROL-123 一問一答自己紹介
Yeah, and the tape's
それじゃあ
rolling.
行くよせーのお名前は
Katt Phloxworthy.
呼び方は
Just Cat is fine.
あなたは何系 VTuber?
Nerdy cat girl who features spaceflight.
誕生日は
May 4th.
年齢は
Older than Pneumatic.
性別は
Transgender
身
female.
長は
4'11".
出身は
Sacramento County.
チャームポイントは
Dialogue hair clip.
突然ですがモノマネどうぞ
Yeah, what's up, Dad?
活動場所は
Twitch, Twitter, YouTube.
はじめの挨拶
Thank you for joining me.
終わりの挨拶
Bye.
推しマークは
Not at present.
配信タグは
Catlight feed.
ファンアートは
Cat pics.
ファンネームは
Cat's apprentices.
好きな色は
Iris Indigo.
好きなことは
Vintage computers and
得意
video.
なことは
Technology.
ここで一言愛の告白好
I love you.
きな食べ物は
Ethnic foods.
好きな飲み物は
Craft soda.
好きな漫画は
Pizza 10.
好きなアニメは
Planet.
好きなゲームは
Left 4 Dead 2.
好きな音楽は
Classic rock.
苦手なことは
Human stupidity.
尊敬するのは
Spacefaring people.
叶えたい夢は
ISS crew
最後にみん
interview.
なに一言どう
Thanks
ぞ
so much for your support and a final status check.
Go Atlas.
Go Centaur.
Go Katt Phlox.
You have permission to launch.
3, 2, 1. RD-180 ignition. Booster ignition and liftoff of Atlas V and Centaur. Hello, everybody, again, and thanks again for coming and thanks for joining me. Hi, Katt Phloxworthy here. Sorry I couldn't get those words out quite the way I wanted to, but in any event, I figured let's, as I'd mentioned earlier this evening during my Borderlands 2 stream, V-Stream unfortunately will be closing down on the 1st of April, so I'm going to try and do as many different flight streams, space flight streams as I can. I'm keeping an eye on what's going on over on Twitch right now because apparently there are some issues going on. My connection says it looks like it's okay. I need to go and look at the stream itself and see how it's looking. Just the there it goes. It's backed up to where it's supposed to be, but let me have a look just to be on the safe side. Yeah, everything looks good that I can tell. Well, actually, I'm looking at the YouTube version of the stream. Let's see. Come on. Trying to find the Twitch stream so I can see the so I can check the health of it. Okay. There it goes. I'm seeing it now. Okay, everything looks good so far. We are going to head over to the we're going to head over to Pad 0C of the Mars or Mid-Atlantic Regional Space Center over at Wallops Island, Virginia, which is the site of a Rocket Lab's Electron rocket carrying a payload for the National Reconnaissance Office on the Live and Let Fly mission, a reference to the Live and Let Die James Bond film, as well as the Paul McCartney song of the same name that serves as its theme. And we're going to be heading there right about now. So here we go. Actually, we're going to go in just a sec here. But in any event, this may end up being a short stream, mainly because, like I said, this is for the National Reconnaissance Office, and the mission in their parlance is called NROL-123. So it may end up being a very short stream. It may end up ending right around the second stage separation and ignition. So let's go ahead and head on down to the. Let's go ahead and head over to the Wallops Island and see what's going on. I need to also unmute the mic on unmute the stream on my side so I can hear it. Hang on a sec. I need to make one fix here. Hang on, stand by. I'm on the wrong machine, I just realized. And I just realized I have the wrong source.
Within the government.
There we go.
For a good team, that's really what it comes down to for me. So we've got so many.
Made
people
one
that are
slight
here to
change
support
and everything
launch,
makes
and
it makes a
everything
whole
has to go
difference.
right. And so to make that happen, you need to have a bunch of people who are really good at their jobs, and launch day is when everyone gets to show what they do. So people who are really
So if you came earlier and you're wondering what I'm about, especially those of you who came in from Deus Rea's raid, here is one of the biggest features I like doing on this channel, and that is featuring spaceflight. And we're now coming from the Mid-Atlantic Regional Spaceport, aka Mars, over at Wallops Island, Virginia, at Pad 0C, which is right next to Northrop Grumman's pad, where they launched the Antares rocket.
Just over 12 minutes to lift off. Things are looking good for an on-time launch from LC2. Our operators are working in partnership with NASA and the Virginia Spaceport Authority to keep the range clear and ready for support. Now, Electron and its NRO payload remain healthy, and the weather is proving nice and calm in these early hours. Next,
and all that white is actually frost that is forming because of the very, very cold liquid oxygen that is filling the tanks, which are not insulated. So it is, and it is basically chilling the air around it, as well as any moisture in the air, forming condensation and ultimately ice crystals on the sides of the vehicle, which is made of a carbon fiber composite. And the vehicle stands about 65 feet tall, and each of the 9 Rutherford engines, which power the first stage, is about the size of a standard kitchen garbage can, believe it or not. Those are very small engines, and they're about to do the go, no-go poll to make sure everything's good.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
Marcy.
RCE is go.
Mars Ops.
Mars Ops is go.
Mars 1.
Mars 1 is go.
NASA GSO.
Let's go.
NASA RSO.
RSO's go.
NASA PM.
SPM is go.
Payload MD.
Payload MD is go.
LSO.
LSO is go.
LD sub.
LD sub is go.
NASA TD. The go-no-go sequence is complete. We are currently T-minus 11 minutes and 7 seconds and counting. We are go for the terminal count at T-minus 10 minutes. From this time, the 3-watt hold.
Hello, Cabbage Bun. How you doing? And we're at T-minus 11 minutes and counting. About to enter terminal count at T-minus 10 minutes. Everything will go into full control of the vehicle itself right around the T-minus 2 minute mark.
Moving forward with today's launch attempt set for 0240 local time, 2340 Pacific time, or 0640 UTC. It is now 10 minutes 36 seconds and counting to launch, so time to take you through the Electron rocket for today's NRO mission. Electron is a 3-stage liquid-fueled launch vehicle. Its external and internal structures, like its propellant tanks, are made from carbon composite, which is what gives Electron its unique black look. Now, where it is white is where liquid oxygen is being loaded into the tanks. The freezing temperature of the LOX causes moisture on the outside of the rocket to turn to ice, and that's why it looks white. There are 10
that's indeed
engines
why.
across the rocket, 9 that power the first stage and a 10th that powers the second stage. All of these Rutherford engines are 3D printed.
So much of that is much the same as the Falcon 9. The big difference is that it's a much smaller vehicle, and on top of that, it is all electrical powered, with the sole exception of the uppermost stage.
Together, drive the engine's propellant pumps. It's a unique but streamlined way of making an engine run while still allowing Rutherford to achieve up to 90% efficiency. Now, the rocket's propellant is a mix of liquid oxygen and kerosene used across all 10 engines on both of Electron's
And the
stages.
kerosene is what is called
On its
RP1, or
first
refined
stage, there is a
petroleum
singular
1.
engine called the Curie. Now, this engine is much smaller than the Rutherford and is used to propel the kick stage, or what we call the third stage, or what we call the kick stage, when it's in space to deploy its attached satellites. Now, we're able to start and stop this engine on command when it's in space, which helps to point the kick stage and its payload in exactly the direction it needs to go, whether that is across multiple trajectory changes on a rideshare mission or to a very specific location on orbit. They can
And
only
the
be
one thing to
achieved
note
from
about
anchor
this vehicle, it is a very small vehicle. It stands about 65 feet tall and carries a very small payload of probably no more than about maybe a couple,
Stage OD countdown.
about 50 or so kilos.
Proceed with sequence 56, the stage
We're
216
inside of
sequence.
terminal count.
Copy. Stage terminal. Check.
Just had something to eat. Cool beans. I ate something. I had a bit something to eat after my last stream.
GCOD countdown.
LTGC.
Proceed with sequence 57, the launch pad ready sequence.
Copy. Proceeding with launch pad ready sequence.
T-minus 8 minutes and counting. And this is much like their stuff down at the Mahia Peninsula. The only difference is they only have one pad. And one of the things you'll also see it's a bunch of water that just before they ignite the engines. That's their water deluge system to absorb a lot of the acoustic energy. And they also do that at both the Falcon 9, Falcon Heavy, and they also did it at Starship, and they're going to do it for SLS as well.
Including a rehearsal for launch that is known as a wet dress rehearsal. Now, Electron starts its journey at our integration and control facility and is then transported horizontally from there to the pad, where it is full steam ahead with pad work to help bring that vehicle vertical once it arrives. Now, this launch's mission manager, Jane McNichol, was at the pad earlier today to check in.
Welcome to Launch Complex 2, where just a few hours from now, from right behind me, Electron will lift off and take to Virginia skies for the first time this year. So far,
and there have been two previous missions that Electron has launched from the United States. Most of them will launch from New Zealand at the Mahia Peninsula, where Rocket Lab has their launch complex.
Ahead of launch at around 2:40 a.m. local time. Once pre-launch checks are complete and all personnel are cleared of the pad, we'll begin fueling Electron with liquid oxygen, and we'll start to see that icy white coating form around Electron's launch tanks in preparation.
And of course, as you can see there's the coating of ice and frost.
Of the show today, just over here to my left, something
in the black area below, I believe, is where the RP-1 tanks are.
Full speed ahead on our pad for Neutron, with concrete foundations for the launch mount board and the water tower construction nearly complete, ready for installation. Standing at just over 86 meters, or around 283 feet, the tower will hold 200,000 gallons of water. As Neutron's Archimedes engines ignite for liftoff, that water will be pumped onto the pad, providing acoustic suppression and heat protection. A similar system is in place to protect Electron's pad, just on a much smaller scale. When you watch liftoff today, keep an eye on the launch mount right about where you see the red handrails are, and you'll see the deluge system initiate in the seconds before launch.
And bear in mind, that vehicle is about 3 to 4 feet in diameter.
But at twice the height of Electron and capable of carrying 13 tons.
And that person out there is a good idea of what kind of scale you're looking at. This is a very, very small vehicle.
For now, technicians are continuing to prep Electron for launch, so I'll hand it back to Muriel in Mission Control.
Coming up on T-minus 5 minutes.
We are now coming up to 5 minutes from liftoff.
T-minus 5 minutes and counting.
2-minute
Mark.
mark to launch that Electron's countdown auto sequence will begin. Now, this is when Electron's flight computer takes over the launch countdown from the operators who are running it manually. Just after Electron has switched to that auto sequence, at T-minus 1 minute and 30 seconds, we should hear the call that LOX loading is complete on Electron. At 1 minute to liftoff, we can then expect confirmation that the launch vehicle's first and second stages are pressurized for launch. And then it's through to T-minus 10 seconds when our launch director will begin the countdown to liftoff. So with the launch vehicle and
looks like they have a hold at T-minus 4 minutes, 36 seconds.
Things are looking good for an on-time launch.
And like I say, scrub disclaimers are always in effect. And any of a number of things could go wrong. It could be weather. It could be equipment on the rocket itself. It could be support equipment on the ground. It could also be the range, which almost delayed Starship's most recent launch, where Boater managed to find himself in the range area. When they talk about the range or a fouled range, that means that vehicles may be in the area, such as aircraft, watercraft, or anything similar.
Has gone into a hold for now, so we'll stand by and wait for updates from Mission Control.
Depending on what the requirements of the mission are, they may have to scrub. Many of those, for example, the anything going to the International Space Station or any of SpaceX's Starlink missions, those use what are called instantaneous windows, meaning they start at a very specific time, and if they cannot be satisfied, it will be cycled to another day. And if you ever hear when they talk about the 3 hold or the words hold, hold, hold being spoken over the communications loops, that means that particular controller has reason to believe that they will not be able to launch, and they will state why, especially during the time when they're in an area where
countdown.
Avionics LD.
Avionics terminal board sequence complete.
Copy thing.
looks like they're scrubbing. In this case, possibly due to an avionics issue.
LED stage countdown.
Stage LD.
Stage terminal board checks are complete.
Or maybe they're
Copy,
doing
thank you,
other
stage
checks. We'll
two.
see what
Please
happens.
Confirm your bleed valves are all open.
Confirm bleed valves are open.
Copy, please configure your OFVs for locks top up.
Well, they might actually be doing. Let's see what they got. And when they talk about oxygen top off,
PLS LD
base-
on countdown.
LD PLS.
Please proceed with the locks top up. Papa 7600.
it sounds like it sounds like they're pressing forward. When they talk about locks top off, it's because the liquid oxygen is so cold and there's no insulation. The oxygen will start to boil off as soon as it goes into the tank, and they have to keep it topped up as the vehicle continues to sit at the pad. And just literally moments before they actually have to ignite the engine, they'll cease replenishment of liquid oxygen, and then then start pressurizing the tanks ahead of liftoff.
Update to share, just to let you know that we have had a hold during today's countdown, with the clock sitting at T-minus 4 minutes and 36 seconds. Now we are listening into Mission Control to understand the driver behind that and see if we can recycle for another attempt. We'll let you know more as we do.
We are now at the T0 mark right now, which is 11:40 p.m. Pacific Daylight Time, or 2:40 a.m. Eastern Daylight Time, or 0640 hours UTC, or sometimes called Zulu. Quite frequently, you'll hear Zulu being mentioned during ULA launches, and many other launches as well. And that basically means the same thing as UTC. So, like I said, it could be an avionics issue. They're still in the process of topping off liquid oxygen for the time being, until they can ascertain what's going on, whether they can proceed, or if they have to do offload of the propellants and then stand down from tonight's attempt. But basically, like I said, any of a number of variables, whether it's the weather, which is a very frequent and quite frankly very fickle situation that happens, especially high-level winds in the upper atmosphere, frequently in the form of wind shear, can keep the vehicle from being launched. And of course, the other ones as well include like cloud cover, especially cumulus clouds. They never launch during the rain. So we're seated at T-minus 4 minutes, 36 seconds and holding on the Live and Let Fly mission for the National Reconnaissance Office. We are waiting for whether or not they're going to be able to do a cycle to a new T0, or if they're going to have to scrub for the day and, for example, try as early as tomorrow. It all depends on what the situation is and what could be causing what could be asking them to what may be requiring them to do a sort of hold on the countdown. And in certain cases, like I've said before, it could be range fouling, like for example, a boat, an airplane, or other craft in the area that the craft will fly through or over. So we don't know yet. But they've been basically told to keep replenishing liquid oxygen. As the liquid oxygen boils off, they will basically keep replenishing liquid oxygen until they either launch, or they go ahead and stand down, at which point they will start offloading the propellant into tanks on the ground. In the case of this rocket, it uses RP1, which is a form of kerosene, a very highly refined form of kerosene, which also RP1 stands for refined petroleum 1, which is much higher in refinement than, say, Jet A, for example, which is what's used in jet aircraft, jet and turboprop craft. Standing by.
The clock remains at a hold just while our mission operations team works through what is the driver behind that. We don't have any new information to share with you, but as soon as we do, we'll bring you another update here and let you know if we can recycle this attempt to try for liftoff today.
And like I was saying earlier, each of the engines at the base of the first and second stage, there are 9 of them, which is much the same as the first stage of the Falcon 9. There are 9 of them, and they're about the size of a kitchen garbage can, and are all 3D printed. Stand by.
Electron is secured on the pad, and ECS is enabled.
Copy, thank you. Then GC, please reprime the igniter system, Papa 4200.
Copy, proceed to Papa 4200.
And like I was saying earlier, this uses an electric pump system as opposed to a turbo pump system, where they burn some of the propellant to turn a turbine, which then drives a shaft, which then drives a pump. And in this case, since it's a Carolox engine, where the propellant components, liquid oxygen and RP1, are about the same density, they can use one shaft. In the case of the RD-180, I think they also use one shaft. The only difference is that they send all of the oxidizer and a little bit of the propellant through what is called a pre-burner, and that runs and then that operates the turbo pump, sending all of the remaining unreacted liquid oxygen and all of the and the remaining kerosene, RP1, directly into the combustion chamber. The Merlin 1D uses what is called an open cycle gas generator. What they do is they burn they burn some of the RP1 and liquid oxygen, and they burn it very, very fuel rich to keep that particular part from overheating, mainly because if that part fails, then you have no rocket engine. You have no running rocket engine. And the first stage dumps the exhaust overboard, but the second stage on the Merlin vacuum optimized engine, or MVAC, they take that exhaust and put it through the throat and the top portion of the nozzle, and use that as what is called film cooling, basically providing a boundary layer between the flame and the inner walls of the throat and the upper portions of the engine nozzle. Basically using that to cool it. And when you see the if we actually get to see the upper stage vacuum optimized Rutherford engine, like the upper stage of the Falcon 9, using the vacuum optimized Merlin engine, the engine bell will also run very, very red hot, and that is perfectly normal. That is radiative cooling. Whereas on the I believe on the first stage sea level engines of the Merlin 1Ds, I believe on the sea level Merlin 1Ds are regenerative cooled, basically where they flow fuel and or oxidizer through loops, and in the engine bell to cool it down. The RS-25 uses it as well. The RS-25 being the Hydrolox, liquid hydrogen, liquid oxygen engine, originally used for the Space Shuttle Orbiter and now for SLS. Looks like they are, unfortunately, if they are actually cycling to T-minus 5 hours, 33 minutes, I will be unable to cover this because I actually have to get up in about 4.5 hours to get ready to go to work. So let's see what they have as far as any status goes. It looks like they pulled the countdown away. So let's find out what is happening, and we'll get some more information on that before long. And I will update where I can. I will update the title of the stream accordingly to indicate what at the time the issue was that they were investigating as to what caused the mission to scrub. Also, another note: a recent flight of United Launch Alliance's Vulcan Centaur went off without a hitch. Which had the Peregrine lunar lander, which attempted to land on the south pole of the moon, but unfortunately, apparently, it tipped over. But the launch vehicle definitely proved to work, and that uses the Blue Origin's BE4 engine, which uses what they say is liquefied natural gas and liquid oxygen for the propellant components. And what they're looking at doing as far as any kind of reuse is not so much bringing back the entire first stage like Falcon 9 does or Super Heavy does, but instead dropping the engine. Now they're at T-minus 12 minutes. I guess they're getting ready to cycle up and start back up. More information before too long. And of course, T-minus 10 minutes is where they go into terminal count. And it sounds like it's potentially an avionics issue. We'll see how things go. And again, as I said earlier, scrub disclaimers apply. So we'll see what happens. I've actually had launches scrub either during the opening minutes when I've lit the stream up or during the theme. If it's early enough or something like that, I will end up terminating the stream on the spot, or it largely depends. And I think that tower nearby, that big tank tower that's up there, I think that's where they store the water for the deluge system. And it sounds like what they were talking about earlier is they're also working on the Neutron launch pad. And they're apparently doing they've done a lot of work already on the Archimedes rocket engine, which too will be using liquid methane and liquid oxygen, much like the Raptor 2 engine, which is on Super Heavy as well as Starship. And we're also one of the things, apparently they're in the process of getting ready for the fourth launch of Starship and Super Heavy. Don't have any specifics out just yet, but apparently they have a lot of different vehicles already built. All they have to do is get them engined and mated together and ready to go. But basically what happened on IFT-3, the vehicle launched, hot staged on time, when they wanted it to, that is when it was supposed to when it was supposed to happen. Apparently the altitudes were the same, but the timings were different as far as when they did the hot staging. And and in this particular context, MECO stands for most engine cutoff. Of the 33 Raptor 2 engines in Super Heavy, they shut down all but the centermost 3, which are the only 3 that can gimbal or steer the vehicle. That would allow them to do the flip and then head it back to the launch site. By and large, that went the way it was supposed to.
Hello
Okay,
again.
here we go.
If you are just tuning in now, I just want to let you know that we are in a hold on the pad at LC2 for the NROL-123 Live and Let Fly mission for the NRO. Now, happily, we do have some time up our sleeve in this window all the way up until 03:25 Eastern. So we may recycle and start the count back up again soon. If we do need to stand down today, though, we do have plenty of backup opportunities in the coming days. For now, though, let's keep up those loops up and listen in for updates from Mission Control.
Okay, so apparently we have about a little more than half an hour left in this launch window. What they'll do sometimes is they'll have a launch window because largely depending on the parameters of the mission. And let's hear what they have to say.
Tank swap is complete, ready to get back into stage 1, stage 2, liquid oxygen top up.
Copy. I'm happy for you to coordinate with stage.
Copy.
Okay, that sounds like they're getting ready to restart liquid oxygen replenishment on the second stage. And that's that second narrower stripe on the very top of the vehicle. That is not that white is actually not part of the vehicle itself. When the vehicle is empty, the entire vehicle is black, mainly because of the carbon composite materials of which the entire vehicle is constructed. When they fill it with liquid oxygen, since there's no insulation, it will chill the outside surfaces of the vehicle, and any moisture in the air will any humidity in the air will be captured by that. It'll condense and then freeze on the surface of the rocket. And I imagine one of the things they do when they design these vehicles, especially when there's cryogenics involved, they will actually take into account the amount of water that ends up condensing and freezing on the sides of the vehicle into the weight parameters of the vehicle. So the minute it leaves the pad, it will also take into consideration about how much water may be on the vehicle itself that is frozen. And another note, on my side of things, once vStream terminates operations, I'm probably going to go back to all my Stream Element stuff. I'm going to keep the overlays as they are here. I'm probably going to make a few adjustments, including in color of the text, because I kind of like the way this looks And so I will be making just subtle changes, because I kind of like this aesthetic better than the other one. So what I'll do is I will make the text black on top of this on top of that tan, and just make a few other adjustments as we go. And also I did a little bit of looking, and apparently Delta 4 Heavy will be making its final flight before too long. Don't know precisely when it will be. I may or may not necessarily be able to cover it live, but if I can, be sure to catch all my socials, and all that information will be out there and good to go for you in case I learn something and I can cover it. Let's see what we got. Since they pulled the count away, or they may have pulled it away, if nothing else, just to say, why do they have the count out there? Well, we'll see. So They're at the hole. They're holding. They originally counted down to about 4 minutes 36 seconds, and then they found. I guess they were talking about avionics over the communications loops, and they're still in the process of topping off liquid oxygen as the oxidizer boils off. And the best thing about that is they can vent it directly to the atmosphere. It'll be absolutely safe because it's oxygen. If this were liquid hydrogen, like in the case of the SLS, or in the case of Delta IV Heavy, which is all hydrolox, both the RS-68As at the first stage, as well as the outer common core boosters, as well as the RL-10 in the DCSS Delta Cryogenic second stage, which is also the basis of the ICPS interim cryogenic propulsion stage, which is on the SLS, which comes off immediately. Here we go.
Just to provide a quick brief. So we're currently still troubleshooting the issue. We have set the new T0 time to the end of the window. That's in UTC time 072500. We're trying to make a decision before the T-minus 12-minute call.
Okay, so basically what they're doing is they're putting the T0 at the very end of the launch window. So basically they're just going to run the clock down, so that way, because we're getting near the end of the launch window, and which is in about 27.5 minutes from now. So then if they run into any issues and they can't successfully troubleshoot between now and the end of the window, they will go ahead and stand down and scrub, detank all stages, as well as any other cryogenics like liquid helium if they use it, LHE, or liquid nitrogen, LN2. The latter of which is being used on Falcon 9. Well, actually, the latter two. Liquid helium, LHE, is used as a back pressurant when as the tanks deplete basically inerting the area where the propellant was as the tanks deplete. And LN2, liquid nitrogen, is used for the cold gas cold gas nitrogen thrusters that are used to adjust the attitude of the first stage as it goes through the as it gets ready to land either on a drone ship or back on LZs 1 or 2 at the Cape, or LZ4 if it's launching from Vandenberg. So I don't know what kind of cryogenic gases they use for this particular vehicle other than LO2, or LOX as it's sometimes called, for liquid oxygen. Now, if they also happen to find it between now and the end of the window and say we cannot fix it now, they will probably call the scrub early, and then of course the broadcast will end and they'll have to recycle to another time and another day depending on the mission parameters. And of course, being something for the National Reconnaissance Office, there's no knowing exactly when that's going to happen, and they won't even publish the inclination. It is now midnight Pacific time, and it's 25 minutes, excuse me, until the end of the window. So it's not so much the I think the T0 in this case is just the end of the window. That's what they mentioned during the course of the last message in the comms loop, to say we're going to keep it there on the offhand chance things happen. But
we just heard the update there from Mission Control that our operators have pushed the T0 to the end of today's window and are working what appears to be an out-of-family data issue. Right now, though, that gives us a new T0 of 0325 Eastern, so let's keep an ear out as we progress through that count.
No specific guarantees of what's going to happen, but basically they're going to continue to work the issue. If it turns out to be something they can fix within this time, they'll go ahead and do that. And once they have been able to fix the situation, they will then establish a new T0 ahead of the closure of the window. Pardon, I was just grabbing a quick bit of water. another thing to note about the second stage, if we were to see any of the video from the second stage, which I somehow suspect we will not, A, should it launch? B, considering the fact it's a National Reconnaissance Office mission, you will see a battery, of which there is also an identical one on the other side of the engine, that runs the pump that moves propellant from the tanks into the combustion chamber. About midway to about 2/3 of the way through the burn, they will jettison those two external batteries and swap to an internal battery inside the fuselage for the remainder of the burn.
And to all operators, LDN countdown, we did find a path forward for the issue we encountered. There are currently no blockers. We are proceeding with our new T0 time of 072500 UTC time. So please be prepared for the T-12 minute go-no-go poll.
Okay. So basically, we're going to find out right at the T-12 minute point where they do the go-no-go poll whether or not they're going to actually proceed with launch. And that will happen in just over 10 minutes from now. And when they do a go-no-go poll, they will check all the various subsystems on the vehicle, as well as subsystems on the ground, as well as range status. Basically, if there are any objects downrange.
There from Mission Control, we have had an update that our operators have cleared the path to launch, and we have a new T0 target of 0725 UTC. So we'll be working through that all the way up to the go-no-go poll at T-12 minutes. We'll come back to you with an update to listen into that.
So it sounds like we're going to actually launch after all. They're going to launch at the very end of the launch window. And in the meantime, we're going to wait on the go-no-go poll in about 10 minutes from now. T-minus 22 minutes and counting. I'm going to do something real quick here. Let's see. Let's see. Okay, there we go. That way people can see as they come in, we now have an established new T0. So in just under 11 minutes, excuse me, just under 9 minutes, they will do the go-no-go poll. Make sure all systems and subsystems, as well as personnel and the range, are go for launch. So basically at T-minus 10 minutes, they will go into terminal count. And then I believe the T-minus 2 minute mark, control of the launch will, looking good so far. Looks like they are finally better than they were before. Apparently there was an issue earlier, which caused them to hold at the T-minus 4 minute 36 mark. They have managed to get things to the point where things are working as they should, and have now established the end of the launch window as the new T0, which is at 12:25 a.m. Pacific Daylight Time, 3:25 a.m. Eastern Daylight Time, or 0725 hours UTC or Zulu time. We're inside of 20 minutes to launch, and in about just under 8 minutes, they will do the go-no-go poll to make sure that everything and everyone, as well as the range, are all go for launch. And to give you an idea of how things are, this thing has 9 Rutherford engines at the base of the first stage. They run a bipropellant of liquid oxygen and RP1. Actually, both stages do that. And the thrust on the first stage is about 36,000 pounds of thrust, or 1,622 kilonewtons. And hang on a sec here. Just wondering why that was. Just wondering why all of a sudden the Epic Games client came to the fore. And the vehicle is about 65 feet tall, or almost 20 meters tall. The first stage has a grand total across all 9 Rutherford sea level engines of about 36,000 pounds of thrust, or 162 kilonewtons. The topmost engine on the single vacuum optimized Rutherford engine on the second stage is about 4,900 pounds of force, 4,900 pounds of thrust, or about 22 kilonewtons. And that comes off at about T-minus 2 minutes.
These final few minutes in the new countdown, let's dig into some of the numbers by this mission. So today's launch will be our 46th launch since Electron's very first liftoff in 2017. It will be our 4th launch of 2024, and also coincidentally our 4th launch from LC2. It is our 5th mission for the NRO, with 4 previous missions launching from LC1 in New Zealand. And to date, Electron has launched 178 satellites, and we look forward to adding to that total today in about 17 minutes from now.
In about 5.5 minutes from now, they'll do a go no go poll to ensure mission and equipment and personnel ready and range readiness status. That includes, and also I think one of the things they'll also say is the status of all the materials, including RP1 and liquid LO2 and any other cryogenic gas that they use. Like, for example, if they were going with, like I mentioned earlier, the Falcon 9 uses several other different gases like LHE, liquid helium. What they use that for is they use that as backfilling gas to basically backfill the tanks as the propellants deplete with an inert gas. They and some vehicles use the exhaust gases in what is called autogenic backfilling, where they basically take the exhaust gases that the vehicle creates and uses that to keep the basically what it does is to keep the propellant tanks from collapsing and maintaining integrity of that for the remainder of the flight. And the other gas that is used during a Falcon 9 is LN2, or liquid nitrogen, and that's used during the first stage's retrieval from after staging. It's used to adjust the attitude when the vehicle is in the vacuum of space, as well as using it for some finer adjustments along with the grid fins when it's in the atmosphere. Coming up on 3 minutes. Anyway, like I was saying, back at right around the T-minus 2 minute mark, control of the vehicle's critical functions, monitoring of the critical functions, as well as control of the countdown will be handed off from ground-based computers to computers aboard the spacecraft ahead of launch. And if it sees anything that could possibly go wrong, it will immediately abort the launch, or a controller can say abort, or hold over the comm loops. T-minus 15 minutes and counting, about 3 minutes away from go no go poll. So the go no go poll, which is happening in just a little bit less than 3 minutes from now. They will poll all the various people at their stations, making sure that everything is ready for launch. That is to say, go or no go, or conditionally no go, or conditionally go, depending on the situation at the time. And first event that's coming up is T-minus 12 minutes, where they do the go no go poll. Next event after that is T-minus 10 minutes, where they go into terminal count. T-minus 2 minutes, where the control handoff happens between ground-based computers and computers aboard the spacecraft. T-minus 14 minutes of counting. And T-minus, I believe, 3 seconds is when they start the sea level Rutherford engines. And T0 is when they let things go. About 2.5 minutes into the flight, they will start just before about right around the 2.5 minute mark. They start to throttle down and get ready to stage, where they separate stages and ignite the second stage. And also, another event that happens within the first minute is Mach 1, and then entry into the area of maximum aerodynamic pressure, or max Q, which is a design point where once they cross that, they are already they've already managed to overcome one of the most important barriers within the mission. If it can't make it through max Q, it can't make it to space. Just as simple as that. Max Q is the maximum amount of aerodynamic pressure the vehicle will experience as it travels through the denser portions of the lower atmosphere. And usually that happens right around the time it breaches Mach 1, or the speed of sound. Coming up on the T-minus 12 minute mark, at which point they will do a go no go poll. So we're standing by for that in about 30 seconds from now. So with bated breath, we await. And all this time, they've still been topping up the liquid oxygen tank, whose contents have been boiling off as they fill it. Here we go.
Proceeding now with the final poll for launch, the go-no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC's go.
Recon.
Recon's go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
Mars CE.
RCE is go.
Mars Up.
Mars Ops is go.
Mars 1.
Mars 1 is go.
NASA GSO.
Go.
NASA RSO.
NASA RSO is go.
NASA PM.
NASA PM is go.
Payload MD.
Payload MD is go.
LSO.
LSO is go.
LD Sub.
LD SEP is go.
NASA TG.
Please go.
And that concludes the go-no-go sequence. We're currently
Okay, the vehicle is now go for launch.
We are go for the terminal count at T-minus 10 minutes. From this time, the 3-bird hold procedure is in effect.
T-minus 11 minutes and counting. And they just mentioned the 3-hold sequence is in effect for the remainder of the count after T-minus 10 minutes.
That confirms we are now going forward with today's liftoff attempt at 03:25 Eastern, right at the end of today's launch window, in just over 10 minutes and 40 seconds from now.
Coming up on T-minus 10 minutes and counting, and entering into terminal count. After that, the next landmark will be, the next milestone will be at T-minus 2 minutes, where control is handed off to computers aboard the vehicle, which will then monitor the health of everything aboard, as well as control the remainder of the countdown. T-minus 10 minutes and counting. Now it's in terminal count. Next event is T-minus 2 minutes, where the control handoff occurs from ground-based computers to the computers aboard the spacecraft. And remember, the most recent time, what happened was everything was there was a problem that happened at the T-minus.
Stage 1 igniter pressure is verified. Hydraulic pressure is verified. LD GC on countdown.
GCLD.
The pad terminal checks are complete.
Copy.
And also during the last 2 minutes, they will start to pressurize all the propellant tanks. They'll also they may say something to the effect of propellant tank press, which is the same thing. And that's basically to make sure that the propellants go to the bottom of the tank.
LD countdown.
LD avionics.
Please proceed to sequence 55. The
T minus
avionics
9
launch
minutes and
sequence.
counting.
Copy. Commencing sequence 55. S-band is switched to high power for flight.
And we should have all the RP1 already loaded. That is a liquid at room temperature.
Stage 2, high voltage batteries ready for flight.
The high voltage batteries are what actually operate the
Stage
pumps
countdown.
to deliver propellant to
LD
the
switch.
engines
Proceed to
for
sequence
combustion.
56, the stage terminal check sequence.
Copy sequence 56.
We're inside of
Proceed to
8
sequence
minutes.
57, the launch pad ready sequence.
Copy. Proceeding with launch pad ready sequence.
T minus 7 minutes and 41 seconds and counting, and the team and the rocket are both tracking well. Now, I just wanted to give you a bit of an update that we are expecting some potential video dropouts during today's launch. So if that does occur, we'll switch views to mission control and continue listening into the team on console for updates.
And again, we may not necessarily get to see much in the way of second stage video, so be prepared. That's because owing to the sensitive nature of the payload, we may not get to see the entire ascent. T minus 7 minutes and counting. So in just under 5 minutes, they will do the control handoff to the computers aboard the vehicle, as well as start pressurizing the propellant tanks, as well as there goes the strong arm clamp is opening up, and then the strong back will retract a few degrees ahead of launch, and when it pulls back, it'll stay there for the balance of the countdown. And in that arm also there are various umbilicals for power, gases, hydraulic fluids, as well as I'm not sure if they do any air conditioning for any of the payloads that happen to go there. There goes the strong back. It is starting to angle backward, away from the vehicle, ahead of launch. Everything's still looking good so far. Haven't heard anything yet with regard to what could be happening. Coming up on T minus 5 minutes and counting.
We are now under 5 minutes away from liftoff, and just a reminder of the final processes as we get towards T0. Electron's auto sequence will start at around the 2-minute mark to launch, which will take over the launch countdown from the operators who are running it themselves from mission control. Now, after that, once Electron has switched to that auto sequence, we should hear the call that LOX has finished loading on Electron at around T minus 1 minute and 30 seconds. Now, 30 seconds later, at T-minus 1 minute to liftoff, we should hear confirmation that the first and second stages of the rocket are at their full pressure for liftoff. And then we get through to T-minus 10 seconds when our launch director will count down all the way to T0. So with the launch vehicle and the payload both looking good and the range being clear, we should be on time for that 03:25 Eastern Time liftoff target. We'll hand over now to Mission Control.
T-minus 4 minutes and counting.
Few calls coming in at around T-minus 2 minutes.
So in less than 2 minutes, they're going to go ahead and do what they called auto sequence start. Basically, like I said, where computers aboard the vehicle will take over from the controllers on the ground, and monitoring health and monitoring health of all the various subsystems on the vehicle, as well as controlling the remainder of the countdown, halting the countdown if it sees a problem, but still allowing operators to abort the countdown in case they see a problem. There is the sequence of events that'll happen. Starting.
Pad auto sequences are. The pad is ready for launch.
We may. Well, I wonder if we're going to get to see that whole ascent. Okay, here we go.
To all operators, LD and countdown.
T-minus 3 minutes and counting.
No red flags.
We're less than a minute until auto sequence start.
LD VCON.
Confirm all expected flight computer ASCOs are green.
Confirm.
Then please lock the auto sequence and confirm.
Auto sequence locked.
At this point, we are go for auto sequence start at T-minus 2 minutes. LD is go for launch.
LD has called go for launch. And about 30 seconds from now, auto sequence will start. And about half a minute later, they will terminate oxygen resupply to liquid oxygen supply to both stages, and then immediately start pressurizing the propellant tanks all the way up until like the T-minus 1 minute, at which point they will call go for launch. T-minus 2 minutes and counting. Auto sequence should have started by now.
Vehicle is on internal power.
They have switched from ground-based power to internal power. They are. We have auto sequence start, and we're calling. They're going to be calling termination of oxygen replenishment at about just under 10 seconds.
Anti-gauging has been disabled. Lock system is in recirculation.
There we go. They have ceased replenishment of liquid oxygen, and they should be pressurizing all propellant tanks ahead of launch. At about the T-minus 1 minute mark, they'll call that all the propellant tanks are pressurized for launch. Standing by. We're inside of 1 minute.
Stage 1 and Stage 2 tanks press for flight.
There's the call. All tanks are pressurized ahead of launch.
Flow engine purge enabled.
And there goes all the little bit of oxygen going out there, and I think they're maybe purging the lines in the T-minus 30 seconds and counting. The lines in the gantry there. 20.
T-minus 20 seconds and counting.
15. 10. 9. 8. 7. 6. 5. 4. 3. 2. 1. Ignition. And liftoff of Electron carrying the NROL-123 mission. It's live or let fly, and the vehicle has cleared the tower.
Beginning pitch over.
They're pitching over. They're doing a pitch maneuver, placing it above water in the event of an abort scenario. There's a view from the second stage. And a whole bunch of decals might be coming off, as well as, of course, lots of ice as well. And and we see
46 Electron is in the air and on its way to orbit after liftoff
coming up
from
on
Launch Complex
breach of
2.
Mach 1,
Electron's Rutherford
and followed
engines
by
are
that
burning
by
hot
max
as
Q,
launch
or
vehicle
maximum
accelerates
aerodynamic
towards
pressure.
max Q, that moment when the density of the air around the rocket and its acceleration through that air creates the maximum aerodynamic pressure that the launch vehicle will experience. The call from Mission Control that we've passed through that point will be coming up shortly.
Could be hitting Mach 1 right about now. About to enter the area of maximum aerodynamic pressure, or max Q. There's the call. It's now experiencing peak aerodynamic pressure as it goes to the denser areas of the lower atmosphere. Shortly after that, they will be the atmosphere will start to actually start. They're calling max Q. One of the biggest milestones and a rocket can go through at this point, if it manages to make it this far, it's already much of the way home.
So
The atmosphere should be thinning right about now.
20 kilometers in altitude and moving at over 2,800 kilometers.
We got
an
about a
hour.
minute left in the burn,
next
at
will
which
be
point they're
3
going to start to
launch
throttle down the
milestones
engines
that happen at roughly the
to
same
reduce
time.
loads on the
To
vehicle
separate the first
ahead
stage
of
the rocket from its second,
MECO,
we
or
need
main
to
engine cutoff
throttle
on
down
all
and
9
shut off the
Rutherford
boosters,
sea
9
level
Rutherford
engines
engines.
ahead of
This is
staging
called
or
MECO,
stage separation
main engine
and
cutoff.
then
Next is
ignition of the
stage
second
separation,
stage.
when two sections will disconnect. And then
And this
it
is
will
my
be
favorite
second
part of
stage
the Electron
engine for
mission,
the
which is
10th
staging,
Rutherford
because that
engine
thing
on
just
Electron.
zooms away
Those
the
three
minute
events
you
are
light up
coming
the second
shortly,
stage
so let's
vacuum
bring up the
optimized
audio
Rutherford
channels
engine.
from Mission
Standing
Control
by
to listen
for
in.
staging, which will happen in just about 20 seconds from now. They're getting ready for staging. Coming up first is MECO, or main engine cutoff, on all 9 sea level Rutherford engines on the first stage, followed by separation of the stages. We have MECO. We have interior views from the interstage on the right hand side. We have ignition, and look at it go. And what you see in the upper right hand corner dominating much of that view is the battery that is powering the electric pump,
That
and there's
is
an identical
MECO
side on the
stage
identical one on
separation
the
and
opposite
Rutherford
side.
engine start on the second stage, all confirmed across the nets. Live and Let Fly is living up to its name as the mission continues nominally on its way to its target orbit. Up next will be fairing jettison, when Electron's nose cone splits and falls away to expose the NRO's payload in preparation for deployment.
And that usually happens right after they pass the 100 kilometer mark, or the Kármán line, which is the internationally recognized border to space. Because now that they're in the vacuum of space, they won't experience any kind of aerodynamic resistance, and they won't need it anymore because it's just added weight. They do not retrieve the fairing halves like they do with Falcon 9. They're saying that battery discharge is good. They just called fairing jettison. I think they're not doing they're not showing the other parameters of the mission because that would
continues nominally for Electron.
Next event will come up right around the 6-minute mark or so, which is when they jettison those outer 2 batteries that flank the engine, switching to a battery inside the fuselage of the rocket for the remainder of the burn.
We are now T plus 4 minutes and 19 seconds since Electron's launch off the pad at Launch Complex 2 in Virginia. Now, as we wait for our next set of mission milestones, we can see that Electron is progressing smoothly through flight. The Rutherford engine on the second stage will continue to burn through that propellant and empty those tanks as we approach engine cutoff for the second stage in just a few minutes. Now, that second stage engine is mostly identical to the engines on stage 1. It contains all of the same 3D printed parts and machinery as a stage 1 engine, but has a larger extension nozzle that is ideal for the vacuum conditions of space, and the engine has the ability to hot swap its batteries. Because the batteries for this engine have been working harder and for longer, they need to be swapped out for the mission to continue. And that is an action unique to Electron, which will be coming up in just a few minutes.
So everything looks like it's operating nominally, and they're tracking right down the middle of the corridor ahead of SECO, or second engine cutoff. Unlike the And on top of that, one of the things that I think Scott Manley was talking about once,
Coming
or
up
maybe it
now
was
on
Tim
battery
Dodd,
hot swap for the
since
second
everything
stage
is
engine.
battery
those
operated,
batteries
they
are
can
close
actually
to
run
terminal
the
now
they can
as
run
the
the
mission is
since they're not
continuing,
using a
so
turbo pump, they
Electron
can run
engine
the
power
they can run
system
everything
will
to
swap over
depletion.
to a new set to keep it running. This hot swap maneuver will allow continuous energy supply.
Hey
to the
Robo, how
Rutherford
you doing?
engine
I hope you're having a great
pumps,
morning.
which delivers fuel into
I'm
the
doing
engine's
well.
combustion
And yourself?
chamber at extremely high pressure. The old set of batteries will be jettisoned, which we might see on our screen when that happens. So let's watch and listen out for the call from Mission Control.
You should be seeing the battery hot swap happening in just a minute. You are right. 12:30. It's 12:31 over here. Yep. Indeed, they were running a lit. Here we go. Coming up on the battery jettison. Standing by. There they go.
Hot swap successful.
They just switched to a battery inside the vehicle itself for the remainder of the burn, which is going to be probably another 2 minutes or so.
Battery hot swap for the second stage Rutherford engine. Propulsion looks nominal. Our orbital trajectory is on track, and we are now just a few minutes away from the second stage's final milestones.
One thing to bear in mind about the Rutherford engine in the Electron rocket, instead of burning a portion of the instead of burning some of the propellant to move the rest of it into the combustion chamber, it uses an electric motor to move a lot of the to move all the propellant into the combustion chamber for combustion. Everything is still running nominally.
T plus 7 minutes, 21 seconds and counting, and the second stage is performing
FTS, flight
well
termination
on this
system,
leg
is
of the
safe
journey.
because
The
they are
burn
too
of
high
this
and too
engine will
fast
take the kick
to worry
stage
about
with
any
its
issues.
NRO
And even if
payload
it did have a
all the way to
problem,
the
it
highest
would burn
point
up in
of
the
this
atmosphere.
mission's trajectory and reach speeds of up to 28,000 kilometers an hour ahead of payload deployment. We are now, though, under 2 minutes to the cutoff of this engine, and we should start hearing more status calls from our mission control operators shortly.
So they've just launched at the end of the launch window. They had a problem. They had a bit of a problem with avionics apparently earlier, and they managed to clear that. So they ended up scheduling it to the end of the launch window.
We'll be repeating the process of the stage separation that we completed earlier in the mission for the stage 2 you see on your screen from its kick stage with the NRO payload. Now this includes second engine cutoff, or SECO, of that stage 2 engine, followed by separation between stages 2 and 3. Now once that third stage, the kick stage, separates, it will go into a phasing orbit of Earth ahead of payload deployment. We'll listen in for those events now.
Okay. So in about a minute or so, they're going to shut down this engine, and shortly after that, they will separate the payload they will separate stages, and leaving the kick stage with the payload on it on its own. And usually what they'll do is they'll reduce throttle to maintain a certain amount of acceleration on the payload. And we're coming up on SECO, or second engine cutoff. We have SECO. We probably will not see the remainder of the mission because of the sensitive nature of the payload, which is perfectly fine.
Good, transfer orbit.
Great news from Mission Control. With that second stage engine cold and the kick stage separated, Live and Let Fly's payload is now further on its journey to orbit. The kick stage has been released at the apogee of this mission's target orbit, otherwise known as its highest point, but not yet on a circular path. It will now complete an elliptical orbit around Earth before the dots reconnect at the apogee. Now when it does, the kick stage's engine will light up for the first of its multiple burns to set the mission on a circular orbit. Next after that will be payload deployment and the release of the payload. Now at the request of the NRO, we won't be live with those kick stage actions or payload deployment calls, but we will bring you updates across our social media channels. Payload deployment will mark the end of the mission for Rocket Lab, but the beginning of those 3 research missions on orbit for the NRO. So good luck and live and let fly to the NRO. We'll be ending the broadcast now, but remember to follow Rocket Lab's Facebook, Twitter, and Instagram pages for updates on this mission and our next Electron launch scheduled soon. This is Lab Mission Control, signing off.
All right, let's go ahead and hit. There's the empty pad, pad 0C, at the Mars location Mars or Mid-Atlantic Regional Spaceport, right next to the Northrop Grumman via launch pad, where they had been launching Antares 230 Plus, which there will be none of anymore because the fuselage was made in Dnipro, which is in Ukraine, powered by 2 engines, the RD-181, later would have been the RD-191 by NPO Energomash, a Russian company. Interesting little bit of irony there. But anyway, that will do it for me. Thank you so much for joining me. Let me see what we can do as far as whom we might raid on YouTube. I don't think we're going to do anything on VStream, but we are going to raid. I think we're going to raid someone on YouTube real quick. No problem, Red Blue Fire. It's always good to have you here. I'm so glad you're here. Let me also open up my own tab. Actually, I'm going to grab it from another window here. Okay. Let's see who might be up at this hour. No, I'm not gonna do that one. Actually, I think I'm just gonna call it a stream because I really have to get to bed. I'm actually already well past my bedtime anyway. But in any event, I thank you all for joining me. And in the meantime, until my next stream, which could be as early as tomorrow. And again, I was mentioning earlier during my Borderlands 2 stream, I have other things that are coming up pretty soon. I hope to have more before too long, but I can't say much of anything just yet. I need to have more information on hand before I do, but let's just say I'm excited, given what I'm doing right now with that information. So, like I said, more is coming soon. I will hope to be able to update you before too long. But in the meantime, until next time, Slava Ukraini, and I hope you enjoyed watching this launch. And until next time, I hope you have a great time and take care of yourselves. And until then, I hope you'll do well, and I'll see you in the next one. Thank you very much for joining me. Bye.